regions of the pharynx. We didn't get a chance to talk about our esophagus, so we will do that now. Keep in mind this is what we did last week. We looked at the various common layers of your digestive tract. The mucosa, the submucosa, muscularis externa, and the serosa. And the basic things we will find in those various structures. Then we started at the mouth and going through each region specifically, saying what they actually truly have in those 4 layers, what they share in common and how they're a bit different. Because the muscularis externa is comprised of a circular and an outer longitudinal layer. What kind of muscle tissue was that? Anybody remember? It's smooth, right? What can you not do is smooth muscle tissue. You can't control it. All right, that's an important thing to think about. All right, so now, in terms of the esophagus, I know it has a mucosal layer. I know it has an epithelial layer. They all do. But instead of the mouth that had keratinized stratified squamose, now we're going to have simply just non-keratinized stratified squamose. Remember, you need squamose you need stratified where we have lots and lots of friction. So like the apple I ate just before we had a little quiz, right? Those are rough surfaces that going down my esophagus, you need multiple layers of skin to kind of protect the underlying structures. So it has to be stratified. It just doesn't need to be keratinized. Let's go look at a picture of that, and then we'll come back and finish the other 2 topics. So there's a cross-section looking down into your esophagus. What I want you to notice is it's not a nice little round tube. It's highly folded, right? Large folds into the mucosa and submucosa. So maybe a part of my apple went down this channel, but didn't go down that channel, right? Or maybe it went right down the middle. But I can actually see that dark purple is the epithelium that's lining the inside of our structure, known as the esophagus. There's my 2 muscularis externa and my submucosa right there. If we zoom in on maybe this part right here, it'll look like that. You know that it's non-keratinized because you can see nuclei all the way to the top layer. You know there's no stratum granulosum layer, no change in color. It's rather uniform, so I definitely know that it's non-keratinized. I've got connective tissue down here with that. And every time you guys swallow, some of those cells are sloughing off and ending up inside of your stomach. Every single time you swallow. That's why it has to be stratified. There are submucosal glands, right, in the esophagus that create mucus to provide more lubrication. It isn't just the salivary glands that are going to help lubricate your food. There'll be mucus glands down your esophagus. And we'll see some consequence of that in the video shortly. Then we get to the muscularis externa, and we have the normal traditional layers of circular and longitudinal, but they're weird. We don't control smooth muscle tissue. So how do you guys initiate swallowing if you don't control smooth muscle tissue?
That was the muscle.
Taz?
Do you have skeletal muscle in the upper third?
Oh, you cheated. Yeah, she's right. Right. The first third of your esophagus is purely skeletal. Because I can control skeletal muscles. I can determine when to swallow that saliva, when to swallow my coffee, and when not to. The second third is a combination of both skeletal and smooth. So you guys should be writing this down instead of just listening to it. It definitely sounds like exam stuff. So look at the pattern. First third is pure skeletal. Second third is skeletal and smooth. What would you guess would be the third third? Purely smooth, right? Forms a nice little pattern of logic. Pure skeletal, combination skeletal and smooth, and finally pure smooth. The last inch of your esophagus is retroperitoneal to kind of anchor it so I can keep it in place so it doesn't waddle all over the place. It's not all retroperitoneal, but the last portion of it is. Now let's go to the stomach. And just to give you guys a little interesting quiz, how many different regions of the stomach are there, do you think? Obviously 4. Why obviously 4? Because there's a blue box around the title and there's blue box. Yes, right? Start looking for things like that to help you learn stuff easier, right? I've got 4 major regions. All right, let's do the top one, the cardia. that's near the heart. It's kind of this area right in here. Just sort of like where the esophagus gets to dump its little chute worth of food, right in there. Now we're going to see the word fundus again later on, but it's a dome-like structural feature. So the easiest way is to kind of think of it as kind of like maybe coming between the word anterior and surface and just occupying all of this. Probably a little bit on the generous side, but that's okay. It gets the point across. This is where the fundus will be. Look at the fundus here. Look at the cardia, about where my hand is. That means from the word maybe surface, where do you think the pylorus region is going to start and stop? Well, they gave me a bracket for it. So how about the body comes all the way down to about there? All of this, right, is going to be the body. And then from here over to there is going to be pylorus. Now the pylorus is divided into two parts. There's the antrum, which is the first part of the pylorus. And then the part right up against what's called the duodenum or your duodenum, or the first part of your small intestine. That last little bit is the pyloric canal. There's going to be a sphincter there called the pyloric sphincter. That's the one we mentioned tonight toward the end of lecture in terms of the enterogastric reflex. That tightens up anytime you have stretch to the duodenum. This is the control valve for letting chyme leave the stomach and going into our little duodenum over here. The stomach is sometimes referred to as a J-shaped organ. I can kind of see the shape of, my J running like this. And so the smaller curve of the J compared to the bigger curve of the J, right? The bigger curve is called the greater curvature. And then the smaller or lesser curve is this part right here. You have the lesser curvature and the greater curvature. You may remember the idea of the lesser and greater omentums because they relate to the greater and lesser curvatures. The lesser curvature has the lesser omentum attached to it, and the greater curvature has the greater omentum attached to it. We know the epithelium is different than the esophagus. What kind of epithelium does the stomach have? You sure?
Yeah.
Yeah, because that's still in pink right there. Okay. So I know it's simple columnar, and the esophagus was stratified squamous. I know there's two layers to the muscularis externa. What are those two layers again? What are they called? You guys remember what the layers of the muscularis externa are? You guys remember what the layers of the muscularis? Longitudinal, not longitudinal. How about, well, circular longitudinal, yes.
Longitudinal circular?
But there's a third layer for the stomach. It has three, not two.
Oblique muscle layer?
That's the new one. It is the deepest of all three. Because there's your longitudinal, there's your circular, and oh my gosh, there's an oblique layer. Because it runs at an angle. Hence oblique. The esophagus only had two. Yeah, different muscle types, but still only two layers. This is all smooth, but it's got three layers. They're trying to keep you on your toes. Now there are little gyri looking like things that we kind of mentioned tonight in the lecture. We talked about a parietal cell making hydrochloric acid, right? Those little folds are called rugae. They have the ability of disappearing as you stretch the stomach out. So they're not permanent, they're temporary. But they do allow for an accordion-like capability of our stomach. Which is why you can put a basketball volume of food inside of your stomach if you train yourself. And a basketball is pretty damn big. Normally for you guys, about a pint and a half is enough. So basically 1.5 softballs. But you can put as much as a whole basketball worth of food in your stomach. And the most I've ever heard of is 28 pounds of food in your stomach in less than an hour.
Those
All right.
crazy YouTube people.
All right? We'll talk about the consequence of that a little bit later. All right. This is just a photograph because you guys are going to be looking at kitties later this week, if not next week, just to really get a hands-on feeling of the digestive tract. But I can see my stomach, so I can see where the cardia would be, and the fundus, and the body, the greater curvature, the greater omentum, a little lesser curvature over here with that. Let's talk about the regions of the stomach in terms of what they offer in terms of cell types and histology. The cardia, right, which remember is just this region right along in here, has lots of mucus cells in it. But the body and the fundus is where I'm going to find my chief cells and my parietal cells. You'll find both of them in the body and the fundus. What part of the stomach produces ghrelin?
The body.
I may said body. What color is the word ghrelin? Okay. Sometimes the obvious isn't so obvious. That's why I try and help you guys. It's color coded, right? The fundus is the origin of, now you know where it comes from. Now, both regions will do chief and parietal cells, which you now know is your pepsinogen and your hydrochloric acid production site. In the pylorus region, right, which remember that is this area here, this area there, is where I'm going to have my G cells and my D cells. That's why it has to be an endocrine signaling system. Those guys are too damn far away for us to do paracrine or autocrine for hormones coming from the G or hormones coming from the D. Yes, we'll have some mucus glands in there, and we have your pyloric sphincter, which we know controls the emptying of food into the duodenum or the duodenum, just to reinforce that idea. And we know the folds in the stomach are called rugae. If we actually look at your stomach, it looks like this. If I just saw that, I'm thinking one of two things: brain tissue or stomach, right? It looks pretty much the same. See how nice and shiny it is? That's due to the mucus, right? From all those little neck cells in our gastric pits. And these are known as rugae. Some call them longitudinal folds because they run lengthwise along the stomach. And we have a fun little video to watch. We're going to be watching a gastric camera going all the way into your jejunum and being pulled backwards out. It's going to go from your small intestine into the pyloric region, into the body, up the fundus, up the esophagus, past your vocal folds, and out. And you're going to be able to get to see what the inside of your stomach looks like and how they go about looking for the possibility of H. pylori. And also realize that even dumbass doctors leave their phones turned on during procedures.
Live recording of our video.
Now we haven't gotten there yet, but I want you to notice these little wall or pleat-like structures, right? Those are going to be permanent because we're in the small intestine. That's how we know it's small intestine. We're going to call them plicae circularis. We have a slide for it. Don't worry about them just yet, but notice these folds are in here. And they're not going to go away. They're permanent. Nice plicae, nice folds.
This is the part of the jejunum, right? This is the second
Look how nice and shiny it is.
part of the jejunum.
It's like lots of mucus.
Now we are in the first part of the jejunum. First part of the jejunum.
They're going backwards.
Coming this off in the jejunum.
There's your pyloric sphincter.
This is the second first part of the jejunum.
They went back in. They're going to pull back out again. But if you look right there, look at that image for a second. Right? Look at the little teeny little pleats we have, these little teeny folds, compared to, if we go back here just for a second, to right there. See, those are way more pronounced. So I can even tell what part of the intestine I'm in based upon that pronunciation. That means I'm in the jejunum, and the latter part is more like the duodenum, like right here, due to the lack of those folds.
Are they still psychic?
Huh?
Are they still psychic circular?
Yeah, there's very few of them.
Okay.
Antral inflammation. This is the body of this is in the antrum of the stomach. This is antrum of the stomach. This
That's
is
a
the
mucus.
fundus. This is the fundus of the stomach. Fundus looks normal.
Empty stomach.
Fundus appears to be normal.
Yeah.
You've got some patchy inflammation in the fundus, so there is a area. Okay, now back into the antrum. If you have the antrum part of the stomach, you're going to take a biopsy to identify whether the patient is having H. pylori, which is part of the infection in the stomach. Live recording, Dr. Radhakrishna here, giving anesthesia for this patient.
Okay.
Yes, I take a bite.
Oh, it doesn't like that, does it?
So those who are having gastritis,
It's a pinprick. You don't even notice it.
you see, you can see the inflamed area, spots. Yeah, yes, yeah.
Yeah, just a tad too slow.
Spots. Yeah.
Right there. See the little dark spot right there? Like a pimple almost right there? Right, those are two other regions of ulcerations where there's an overpopulation of H. pylori perhaps.
Yes, yeah. Erosion, anything erosion, early erosion, or erosion. Okay. They are coming out now.
Still going backwards.
Now it's in the body, yes, it's the body of the stomach. Those are called the longitudinal folds of the stomach.
Alright, so those are the rugae. Look like long little pleats. Allows for the expansion of the stomach.
Okay, coming out slowly. Coming out. Now I'm at the cardiac junction.
That's the esophagus stomach region, your cardiac sphincter or esophageal sphincter.
The two mucosa
And
there, one.
where's my keyboard? Holy crap. Whoa! Okay, back up here. Your little snot, quite literally. There's a space bar on this damn little thing. Get these tiny little keyboards.
Coming out. Now I'm at the cardiac junction.
See that bluish stuff?
Yeah.
That's mucus.
Oh.
So it's evidence of having lots of mucus in the esophagus. And as they pull the camera out, realize what this esophagus is trying to do is trying to
Close up.
suck around the camera. Because remember, it's a closed loop. It's not a big open airy tube. This is only large and expanded. They're shutting gas down your digestive tract. You're a big bloated patient right now, full of gas.
Whoa.
The two mucosa there, one the white teeth.
You have to expand all the tract. You use gas to do it. That's that hissing sound you hear. There's the folds of the esophagus and the mucus. See how it's closed? There's a good amount of mucus right there. Keep going backwards.
You just see like it's got 100 people on.
Yeah, they're going slow.
Vocal cords.
Ooh.
There's your vocal folds. Folds, dumbasses. And out. That's you on the inside.
Oh.
Okay.
Rough.
Is that mucus different than snot?
No, same stuff. Glycoproteins. All right, so with that then, come on. There we go. We can look at a cartoon that represents our digestive stomach area. And so what you just saw on camera was those rugae. Those are the longitudinal folds. And so it's a fold of tissue, right, kind of like this, that create these little pits that are called gastric pits. And the base of all the gastric pits are glands that contain our chief cells, our parietal cells, our G cells, and the D cells. And then, of course, you have your normal submucosa, your not so normal muscularis externa, which you now realize, oh, they're showing me all three layers. I realize the oblique layer is the closest one now to the mucosa, where normally it's just the circular layer with those.
Is there
No,
There's not?
no, there's not.
There's not a plexus of Meissner in that?
There's supposed to be. Well,
Okay.
the Meissner plexus is right there.
Well, that's my interior.
I'm sorry, my enteric is right there. The submucosal plexus is right in here.
Okay.
Can't you see it? I see it. No, it's supposed to be, but it's
Okay.
not.
Okay.
All right. So again, to remind you about a gastric pit and gastric gland, when you see things like this, it is your all's responsibility to realize that this is maybe just a template of what you might find in a gastric gland. Because you know from previous slides that not all these guys are in the same place in the stomach. But they are found in a gastric gland. Just in different regions have different cell populations. But also we have these nice little neck cells. And so in our diagram and lecture tonight, when I did the rugae, and those are my simple columnar cells with the blue mucus we had in the lecture tonight, these cells are exposed to lots of hydrochloric acid. So they can't live very long. They're going to be replaced on the average about every 5 days for an average lifespan. Because they're going to get worn out. They're going to get damaged. So you got to keep new cells always showing up.
Is that the 3 to 7 monthly?
What it says up there, yep.
Like average 5?
Average 5. Pick the middle of the number.
And it's for all the cells, like gastric pit and gastric gland?
Mainly for the ones that are up here.
Okay.
These guys had different life cycles because they're not too, especially these guys, there are no parietal cells down in here, so they're not going to get that damaged by hydrochloric acid with them. But in terms of your stomach lining, all right, every 3 to 7 days, you get a whole new stomach lining in a sense. All right, off to your small intestine. And it's color-coded for you. The blue is the duodenum or the duodenum. Then the purplish is my jejunum or your jejunum. And then this, whatever color that is, reddish, is going to be the ileum. Well, on the average person, and different books are going to give you different dimensions, different lengths. So we're going to go by what I give you as our little rule. So don't go quoting somebody else. Remember, a part of this trick is, can you memorize what we tell you to memorize in terms of the game of academics? So, duodenum is 10 inches. That's pretty much common through most books. That's basically a little bit less than $2 bills laid down side by side or end to end. Because the dollar bill is 6 inches. The next two, though, vary from whatever book you're looking at because of whatever person they dissected, they did an autopsy on. On average, you have about 8 feet for jejunum. Oh, that's nothing. 8 feet. Yeah.
Can't be bigger.
We'll get there.
I was about to say, the smaller you are, is it smaller? It's like 8 feet.
11 and a half feet for an ileum.
11 and a half.
Uh-huh. So what's an 11 and a half? What is 11 and a half plus 8? Plus another 10 inches? That's 20 feet of small intestine right there.
Wait, 1.5 feet? Wow.
All right? So the next time you're staring at somebody's belly going, oh my God, you've got 20 feet? That's just your small intestine. How do we pack it all in there? Well, look at the models next time, right? Look how convoluted that is. It's all packed up. But if you unwound it, you're going to get to about 20 feet of that little stuff. Now, Tam's is a little shorter, because she's just a little less in height. An NBA basketball player who's 8 foot 10 inches tall, 8 foot, I'm sorry, about 7 inches, 7 feet 10, right? They might have a 12 inch long duodenum. That might be 10 feet, that could be 15 feet. So the bigger you are, the more you're going to have. The smaller you are, right, the less you're going to have. It is proportional. That's why you can't just take any book and go, oh, that's the average person's. It depends on who you're looking at. But we can give you some numbers, and roughly, 8 feet, 11.5 feet, 10 inches is a pretty good dimension to look at. And if you look right here, you can actually see the plique, those little ribs we're trying to show you, right in there. Well, let's reiterate the function of all these different regions. We know it's going to play a role in the mixing of chyme, because we just saw it arriving in lecture tonight from the stomach into the duodenum. I know it's retroperitoneal except for the last 1 inch of it. So maybe the first 9 of the 10 inches are behind the parietal peritoneum. So that's what retroperitoneal refers to. But what do you guys have as the function of the duodenum from tonight's lecture? Controls the rate of gastric emptying. In other words, how fast food leaves your stomach. It's going to be the boss of that. And that's what Wednesday's lecture is for. The jejunum is where you do 90% of your absorption of most all of your nutrients. The first 90% get to be reabsorbed in jejunum. Kind of like how we did that 99% of organics in the proximal convoluted tubule idea, right? We're going to have the same idea here. All right? That's due to the huge surface area we're going to have in our jejunum. It has the most surface area of any of the 3 parts. That's why it can do most of the absorption. We will also talk about enzymes coming in, so the majority of my chemical digestion and absorption is going to be taking place in the jejunum. Oh, don't break that camera.
Did you say reabsorption or absorption?
Absorption, right there.
Oh.
Now the ileum, you're going to get very little absorption taking place. But it is going to be the place where we're going to connect to our large intestine. And we're going to use what's called the ileocecal valve to do it. That's the valve from the ileum to what's going to be called the cecum in a couple of slides from here.
There's another C in there. It's cecal.
Ileocecal. There's 2 ways to spell that, I believe. I think there's 1 C and a 2 C. I'll check that. But we got so many variations, kind of hard to keep track of sometimes. I think there's supposed to be 2, but I think you can have a variation of 1. I'll look. All right, so mucosa. Remember, that's the epithelial lining of your intestinal tract. In the small intestine, it is now divided into what we call those plicae, those permanent folds that we saw in the video. On top of the plicae is another layering known as intestinal villi. And on top of those is another lining, or layering, I should say, of what are called microvilli. Let's look at a picture rather than trying to make sense of the words. There are the permanent folds, look like pleats, right? Or baffles in an air conditioning system, right? They're also known as circular folds, but the plicae circularis is the anatomical term. They don't go away, they always stay there. And if you look right along in here, there's a bit of a fuzziness to that appearance. Kind of like a velour or velvet-like texture. A cartoon of it looks like this. So there's the plicae, those are the folds we saw in the video. One of these little folds right here is this thing right there. Imagine taking a carpet that's laid flat and now bunching the carpet up, creating a fold in the carpet. Right? So that is what the plicae is. It's the fold of the carpet. And then these little finger-like projections called villuses, or collectively the villi, are the fibers of my carpet that are coming off of the fold. So every one of these things right here is one of these things right there. And that fuzziness we saw right here, you can barely see it. Those are the villi on the fold. Now we're going to zoom in on those guys. So another way of looking at it is this. We're looking at maybe just this part right here, right? Just right there, or maybe just right here. Just all the villi sticking up. You can't see the plicae anymore, but I can see the little finger-like projections. Now, the pink line that you see covering right along through here. That's the epithelium that covers every single villus. And when we zoom in on the epithelium, it's going to look like this. This finger-like projection is a villus, which is this thing right there, and also that one, which is one of these little fuzzy things right here. When we zoom in on them, I realize they're covered with simple columnar epithelium. That's cool. That's the epithelial part. And on the apical side, next to the food, there's my microvilli. So there's always little finger-like projections that are covering a villus, and the villus are covering the plicae and all of the rest of your mucosa. And that's the architectural creation of from microvilli to villi to plicae circularis. That gives you a huge, ginormous surface area for lots and lots and lots and lots of absorption.
Wow.
Now, don't forget in our small intestine with the submucosa, as we mentioned tonight, your very first exposure was the idea of the cephalic phase and the idea of the parasympathetic nervous system. When you hear food, see food, and smell food, I said activates these things called Brunner's glands and create lots of mucus. Well, those are the Brunner's glands. They're also known as duodenum or duodenal glands. They're simply just glands in the duodenum. And they make copious amounts of mucus. Remember that they're activated by the parasympathetic, and they are inhibited by the sympathetic. So turn them on with the para, and turn them off with the sympathetic. Oh, yes, we didn't do this. So now here, right, we can see in the submucosa, right, there's your little plexes. And I have my little finger-like villuses along in here. And I know that even these guys have a certain lifespan to the epithelial cells. So there are these pits. Now you got to remember, we're not in the stomach. This is the small intestine. So these are not gastric pits. These are intestinal glands, not gastric. And these pits create what are called the crypts of Lieberkühn, or Lieberkühnen. And in there are stem cells. There are stem cells at the base of these. And they get to do lots of mitosis to create lots of new epithelial cells. So as these guys get worn out, I get to replace them from the stem cells in the base of my intestinal glands.
When they flake off, do we poop them out? Is that right?
Yeah, probably not.
Or PM?
Probably just
Because you
readjust
just
them.
completely digest them and use all the little parts. Oh yeah, we didn't talk about that. So since it's all Scott's fault, but here's what you guys need to do or should do over the following week, and I'll remind you guys on Wednesday of this. We're talking about your digestive system. So a little side note here. You want to know how fast your digestive system works. So I have a little voluntary homework, which nobody will do. You guys always chicken out on me.
I'm gonna do it,
I'll do it.
as long as it's not
I
good.
might do
I want you to have a can of corn the next day or so.
Oh,
Oh,
I've done this so
man.
many
And then
times.
look for the can of corn coming out.
It's like the next.
All right? Or lots of tomatoes with skins.
See?
All right?
Tomatoes too?
Tomatoes. The tomato skins aren't
That's what I'll
digestible.
do.
All right?
Really?
I want you to see how long it takes you to poop out the corn after you've consumed it. It's called your transit time. All right? Mine's about 12 hours or less.
Yeah, mine's
All right.
nice.
And so it's a good marker. Or lots of peanuts. All right? Because they're hard to digest.
So the faster you digest, what's the benefit of that?
There's no benefit. It just is for the
Usually just
moment.
faster. Okay.
Yeah. I mean, there might be a downside to it actually, or benefit. It depends how you want to look at it. Yeah, you can't get nutrients, but I also can't get calories. That's a good thing for that. So have a can of corn, all right?
Okay.
And then see how long it takes for you to see the can of corn again. Okay? Now, with that idea, whoops, is this, speaking of cans of corn. We know that the last part of our small intestine is the ileum, right? And over here we have the cecum. Now there's the valve, which they did use only one C.
Well, that one is two C's.
There's-
Sequel.
That was a different valve.
No, it's.
Oh, I
different
see it, they did do that too.
Yeah, these.
I see what
Did I-
you're saying, yeah.
Come on, will you work, you silly little thing? Oh, I mean, I am missing that C. I'm sorry, you're right. I thought you meant CC. C. No, in that case, there are two C's, yes. I think it's CC and then another set of letters. All right, come on, faster. You're too slow. Thank you. All right, large intestine. How many different regions do you think there are to the large intestine?
Five.
No, different regions.
Four.
How many different colors do you see?
Three.
Oh, three.
Three.
Well, different colors, right? How many different sections are there of a colon?
Four.
Oh.
Yeah, there you go. All right, so our large intestine has three major regions. The cecum, the colon, and then the rectum. Okay. The cecum is the very first part, and there's a big gigantic valve you guys are going to be looking for probably on Monday of next week, with your eyes closed, with gloves on, in the kitty's gut. This valve is as big as your button, and it's very easy to feel. It's a very thick, muscular valve. I want you to notice it in the kitty cat's little large intestine. And it's going to be what allows stuff to go from the ileum into the cecum itself. Then we have the first part where I'm going to like ascend up my colon. So what do we call it? The ascending colon. I'm then going to go traversely across the abdominal cavity. So what do we call the transverse colon? Because we're going across. I'm then going to go descending down my colon. So what should we call it? How about the descending colon? So these parts make sense. Ascending, transverse, and descending. And now right about here, you're going to get the sigmoid colon, right along into here. And then from there we go into the rectum, the last little segment. I can see my nice little superior mesenteric, which I realize supplies all of my small intestine and my ascending and my transverse. And my little pathetic inferior mesenteric is simply doing the descending and the sigmoid and the little portions of the rectum over here. But it's not a really big contributor. But when I look at this, I get to see these little pouchy-like things right along in here. And what are these little pouchy things called? Yeah, it's called Hofstra. Which really sucks if you went to Hofstra University in the northeast of the United States. There's actually a university called Hystra.
That's H-O-F.
Yeah, but it's pronounced Hofstra. I wouldn't want to go there. But, you guys ever seen those?
You're good.
Yeah. Oh, of course you have. This is your poop. Alright? The next time you see your poop, you should be looking at it, right? It has this little sausage-like appearance. This is the imprint of the Hofstra. If you grab clay and squeeze it, right, to let go of it, you can see where your fingerprints were, right? Well, this is the impression made by the Hofstra on feces, when feces has a certain amount of moisture or a lack of moisture. Diarrhea, of course, all bets are off with this. But you're actually seeing the imprints of the Hofstra on here. Now, what are the two major layers, or the two only layers of the muscularis externa? And which way do the circulars go? They go circularly around. And which way do the longitudinals go? They go lengthwise, right? Except for here. The circulars are normal. That's nice. Now, this here is a representation of, I took your large intestine, I took my scissors and cut along the entire length, and I unfolded the intestines. So here's your flattened out intestine. Now normally, my longitudinals run all the way across. But if I gather them up into strips or bands, where now there's no longitudinal here, it's only here and here, we call those tinea coli. They are the strips of the longitudinal fibers. And that's these things right here. Which means right there, there's no longitudinal tissue. There's no longitudinal tissue here. Just right there.
So,
But if you follow it, right, realize this tinea coli is not that one. That one's on the posterior side. There's actually 3 of these strips, and they can only show you 2. This one and then that one, running along through there.
So the hostras there's just circular.
They're just
there.
pouches, yeah.
So there's a circular muscle there, there's no longitudinal except right along the ridge there, Bethany, is that?
Yeah,
what
I mean, this whole thing is a hostra, so it's more like where the circulars are kind of crimping the tube a little bit. And there's definitely, there's no longitudinal here, but there is that strip which is still a part of the hostra. Kind of runs like down the middle of a hostra if you want to.
There's only one strip of the longitudinal, the rest of it's just circular.
No, there's 3 strips. There are 3 bands of taenia coli
No,
around the large intestine.
what I mean is where the tinea coli is, there's a strip, and then in between them, there's no longitudinal.
Right, exactly, right. In between the strips, there's nothing. But you said there's only 2 strips or only 1 strip. Yeah.
Where's the third one?
Yeah.
It's at an angle. It'll be right about here at a 45-degree angle with them. But yeah, where you don't see the strip, there's only circular muscles wrapping around. Where you see the strip, there's longitudinals.
So there's 3 strips down the length of the colon?
Yep. All right, let's look at the mucosa. Because you guys have some study guide questions that ask you to compare the mucosa and muscularis externa of various regions of our digestive tract. And first go back and review, because this thing is just going too damn slow, because I go faster than you do. It's really irritating.
Your battery is dying.
No, I'm just getting too fast for it. They're fresh batteries. That was happening yesterday at home when I was trying to work with this thing. So let's go to what am I looking for here? I'm looking for this right here. All right. See all the nice little villi? All right. Lots of surface area, small intestine, jejunum, lots of absorbing, plicae, microvilli, villi, and then you get here. Boring. No folds, no villi. So if you were an alien scientist and you started dissecting somebody and you came across this region in the intestines, you know automatically it doesn't do a whole lot of absorbing. Surface area is key to gas exchange, filtration, reabsorption, and absorption. So there are no plicae, there are no folds, there are no villi, and very little microvilli. I can see my nice little supracolumnar, that's cool. I can see pits. Remember, it's not gastric pits, they're intestinal pits. And then I realized that there's lots of these little white cells that I really didn't have when I go back and look at the idea of, come on,
Goblet cells.
faster you little bugger. Right in here. Yeah, I have a few goblet cells, but over here, faster you fool, you fool. Lots and lots of mucus. Because we're going to talk about, starting a bit tomorrow, is, come on, when you guys start getting food to go from here into there, you've got about 1,500 milliliters of moisture at the end of the day. That's 1.5 liters. By the time we get to here, you're down to about less than 500 mils. So that's a lot of moisture taken out. We're going to start with 9 liters, by the way, and end up with just about 1/2 liter here. So what does the stuff look like over here? Well, next chance you get, I want you to go play with a nicely fresh, wet cow patty.
Yeah.
That's what your poop is like about this region of your colon. Rather fibery, there's some substance to it, but it's also kind of moisture ridden. Right? But it's kind of rough. And I need to create lots of lubrication, which is why we have all these goblet cells, to provide lots of mucus. And you may have witnessed their productivity.
Yes.
The last thing you guys may have had a kind of an unpleasant case of diarrhea, right? Now you think about throwing up for a second. You have dry heaves, right? Where you're still going through the motions of throwing up, but all you get is mucus coming up, right? Well, the same with diarrhea, right? Where you've had enough diarrhea, now there's nothing coming up, but you still have the cramps and the active pooping, and you get this kind of a mucusy discharge, right? That's from these goblet cells. That's the mucus you're seeing. To provide nice lubrication so the feces have an easier time to leave. And you can also notice what they're trying to show you right here. All right? There's your circular, but look what they did to the longitudinal. Right? And when I hound you guys about look, but don't look, but look, I realized the longitudinals don't go all the way across the diagram. They've created strips. Whereas if I look at other diagrams showing me longitudinals, they cover the entire width of the diagram. So they're even trying to show you the idea of the Taenia coli by just physical features of it being gathered. Now there is, I think it's the Brown book. It may not be the Brown, maybe a version before, but my Martini textbook over there that some of you tend to use because you didn't bring your own book, had this asked backwards. They have that labeled as the circular and that labeled as a longitudinal. All right? It took them like 8, 9 editions to go, holy shit, we have a boo-boo here. I'm not sure if it's this one or the previous one prior to that, but realize this is accurate, this is correct. All right? The outermost layer always has to be longitudinal. The inner layer closer to the mucosa in terms of the intestines, excluding the stomach, always has to be the circular layer. All right, let's get to the rectum. The function is to store your feces until it's time to defecate, time to expel, time to poop. It's a place just to store your feces. Now, the active pooping can create lots of friction. So we have to look at different types of epithelia that can be found in the rectal area. Oh, come on. Thank you, you're so slow. In the anal canal, you have columnar, but in the actual anus, where the actual friction and pressure is created, you need stratified squamous. So you're looking at this idea. We'll come back to those guys in a moment. Right? This epithelium, since there's a lot of pressure there when you take the feces and try and push it out, I want lots of protection of underlying structures, so I better have stratified stuff there. I don't have to be stratified up here. I can be just columnar. I'm not worried about the pressure and the friction. But then the actual sphincters that allow you to either keep the feces in or give you permission to remove the feces, right, is this idea of the two different sphincters of the anus. There's the internal sphincter here, and then the external sphincter there. And this is where you got to really focus about paying attention to what kind of muscle tissue you're looking at, and realizing the significance of when someone says, oh, well, that sphincter is made of smooth, but oh, this one is made of skeletal. Because we'll talk about the physiology of the actual defecating motion later, but when the feces comes down here, it's going to create stretch basically. And we're going to get a 2-for-1 reflex. Automatically, when the feces gets here, it creates a reflex to relax the internal sphincter. And oh, thank God, automatically to contract the external. So that you have permission and the appropriate time to actually poop. That gives you control. Gives you voluntary control level. John hasn't shut up yet. I'll go poop after he's done talking. Rather than, oh my God, I got to go right now, and you go right now. You lose control of your defecating process. Little kiddos have to learn this sensation. That's what potty training's about. Realize that sensation, I can actually control it. I don't have to go right now. And we're going to talk a little bit about diarrhea and different stages of diarrhea. But has anybody ever had to either well, you won't admit this, we'll talk about it this way, have to administer an enema? Okay. So why do you give an enema?
Constipation.
Constipation. And what is constipation?
Not pooping for a long time.
Right. And so the poop sits there, right?
In the other case is compaction, where the poop is so dried out that it can't be.
Well, hang on here. Just slow down, dude. You're getting there.
That's
Just
really
slow
when
down.
you need an enema.
Just slow down, right? Right? So if it stays there for a long time, Dave, what happens?
It gets so dried out it can't.
Why does it get so dried out?
Because the large intestine is always extracting moisture from feces.
Yes. All right. Which is why you have to have regular movements. If it stays in, it gets more like rocks. And so what do? If the fleece doesn't work and the enema doesn't work and the suppository doesn't work,
Manual removal.
you glove up. And you're going to give an anal massage. The proctologist's favorite finger. Right? Because when you go up, well, that's why they use the longest one. I mean, come on. Right? And you massage the anus, you stimulate the muscles to relax, hopefully, to to allow for the lubricated feces to expel out.
So I had an enema, but it was due to they couldn't see my organs because they were so,
That's different.
I guess like blown up or something. So
Mhm.
why would they do an enema?
Just to get rid of the presence of the feces, they're creating a cloudy-like image in your film,
Okay.
and just to remove any material inside.
Okay. Well, they didn't even need to do one in the first place. Stupid.
That's where I make some money.
Oh my god.
With the anus, are we talking keratinized or non-keratinized?
Non-keratinized.
Okay.
And how do we, does anybody know how we know that it's non-keratinized?
It's inside of it?
No?
It's inside the body?
Well, in a way, yeah, but there's even a better way to remember it.
So that's-
The Romans
They're Romans?
would do cocaine up the anus.
Oh.
So it would get.
In the circulatory system really fast.
Oh, yeah,
That's
yeah.
crazy.
That's called pooping.
Don't get any ideas now.
We're all like,
But it's a nice mucosal membrane. It's very crazy. All right, we're going to stop there, ladies and gentlemen, on that little happy note of taking suppositories and cocaine up the butt.
You know.
Okay. Keep in mind that you guys have another quiz on Wednesday. It's much bigger than today's quiz. And the one after is even bigger. But there is no quiz a week from this